Okay, this is lesson 76, and we're going to be talking about multiplication with scientific notation. Remember, deci means 10, and our number system is called the decimal system because we have 10 digits, 0 through 9. That's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, which makes 10 total digits. And because of our place value system, it's based on factors of 10. For example, when you have 333,333,333, as we move from digit to digit, starting from the right, each 3 is worth 10 times more than the 3 before it. So if you look on the far right, you've got 3. That first 3 is worth 3. The second 3 here is worth actually 3 times 10, or 30. This one's worth 3 times 10 times 10, so 300. So each time you move across our place value system, each digit is worth 10 times more. So that's part of why our system is called the decimal system. And so when we multiply numbers by 10, by powers of 10, like 10, 1,000, 10,000, 1/10, 1/100th, all we have to do is move the decimal point to the left or right to change the value of each digit. So, for example, in 3.2 here, when I multiply it by 10, the 2 that was 2/10ths now becomes 2 1s, and the 3 that was 3 1s becomes 3 10s. So really, I'm just moving the decimal point to the right, and I get 32 when I multiply that by 10. If I multiply 3.2 by 1,000, I move the decimal point 3 places to the right, so I would have 3,200. If I multiply 3.2 by 10,000, that's 4 zeros, I would move the decimal point 4 places to the right, so I would get 32,000. So each time you multiply by a power of 10, you're moving the decimal point. If it's a number 10 or greater, if it's a power of 10 or greater, then you are going to move it to the right. If it's something like 1/10 or 1/100th, you move that decimal point to the left. So for example, here you've got 3.2 times 0.1 or 1/10. That means you're going to move the decimal point 1 place to the left and get 0.32. If you multiply 3.2 by 1/100th, you'll move that decimal point 2 to the left, so 0.032. Right? So that's only possible because of the way our place value system works, that each digit, as you go from left to right or right to left, it's a power of 10 less or greater than the one before it. All right, so that's why we use scientific notation, because our numbers are easily written as a digit multiplied by a power of 10. Okay, so if I want to multiply some numbers in scientific notation, I can, here's one way I could do it. All right, this is not really the way we're going to do it, but this is one way I could do it. I could look at this problem, 4 times 10 to the 5th times 2 times 10 to the negative 2, and I could multiply out each parentheses. So 4 times 10 to the 5th would be a 4 with 5 zeros, which is 400,000. And then 2 times 10 to the negative 2, I would move that decimal 2 to the left and get 0.02. And then I could multiply those numbers out. So 400,000 times 2 100ths. I could cancel 2 of the zeros and I would end up with 8,000. And then I could write that in scientific notation as 8 times 10 to the 3rd. Right? That's one way I could do this problem, but that is not the way I'm going to do it. There's a much more efficient way to do it. All right, so this is my problem, remember, up here. 4 times 10 to the 5th times 2 times 10 to the negative 2. Since multiplication is commutative, remember, that means you can multiply these 4 numbers here in any order you want to. So you can multiply 4 times 2 and then 10 to the 5th times 10 to the negative 2. All right, 4 times 2 is 8, and then the power of 10, I've got 10 to the 5th times 10 to the negative 2. When you multiply like bases, the bases are both 10, you can add the exponents. So 5 plus negative 2 is 3, so 10 to the 3rd power, and that's the answer. All right, so that was actually step 2. All right, so don't do it the first way. Do it this way. Just rearrange the numbers. It's all multiplication. So just rearrange the numbers, multiply the numbers that are not powers of 10, and then add the exponents on the powers of 10 to get your final power of 10. All right, so here's another example. You've got 3 times 10 to the 8th times 3 times 10 to the 3rd. Rearrange it. 3 times 3 times 10 to the 8th times 10 to the 3rd. Multiply the 3 times 3 to get 9. Add the exponents on the 10s. 8 plus 3 is 11. So 10 to the 11th power. And you're done. Here's another one over here. 4 times 10 to the negative 6 times 6.2 times 10 to the 4th. Rearrange them. 4 times 6.2 times 10 to the negative 6 times 10 to the 4th. Multiply 4 times 6.2, that's going to be 24.8. And then add the exponents on your 10s, so that's going to be 10 to the negative 2. Negative 6 plus 4 is negative 2. And now you're almost done, but this is not written in scientific notation right now. This is because, remember, in scientific notation, you only want one digit to the left of the decimal point. So you're going to need to rewrite it. 24.8 can be written as 2.48 times 10 to the 1st. Right? Because if you move that decimal to one place to the right of the first non-zero digit, which is 2, and then you think about how far you have to move it to get it back to where it was, that's one place. So I just wrote 24.8 in scientific notation, and now there's also this 10 to the negative 2 over there. And now finally add the exponents on those 10s, and you're done. This would be the final answer for that, because you want to have only one digit to the left of the decimal when you write something in scientific notation.